Hello everyone. Today we are starting a new topic, that is integration. Before we study the definition of integration, let's see what is the antiderivative of any function. So here the function f of x is equals to x square. So the antiderivative of this function x square can be given as capital F of x is equals to 1 by 3 x cube, right? So when we differentiate this function, right, d by dx of the given function of antiderivative, what will get 1 by 3 is that constant, and x cube derivative will be 3 into x square. So here this 3 will get cancelled and we'll get the function value as x square. So we can say that f dash of x is equals to f of x. So here here the antiderivative is nothing but the integral of the given function. Okay, so we can say that integration is the inverse of differentiation. Okay, further we'll see a little example. Here I have taken the same function, which is the antiderivative, plus the constant value I have taken as 5. Again, if we differentiate this equation, we know that the constant derivative is equal to 0. So again we'll get the function value as x square. So here the constant value has no meaning in the result of the function, right? So we can say that there will be a constant for the antiderivative. If there is any function f, the antiderivative will be small f, and c is any constant of that function. So d by dx of f of x plus c is equals to f dash of x plus 0, which is equal to the given function f of x. So the definition of the integration can be given as a function f of x is an antiderivative of a function f of x if f dash of x is equals to f of x for all x in the domain of f. So it can be any value of x, right? Consider, let f be any antiderivative of f. The indefinite integral of f of x with respect to x is defined by integral of f of x dx is equals to f of x plus c. Here c will be the constant of integration, and the process of computing an integral is called as integration. Here f of x is called the integrand, and the term dx identify x as a variable of integration. Let us look for the formulas used in the indefinite integrals. Integral of x power n dx is equals to x power n plus 1 by n plus 1 plus c is the constant of the function. Integral 1 by x dx is equals to log mod x plus c. Integral a power x dx is equals to 1 by log a into a power x plus c. Integral e power ax dx is equals to 1 by a into e power ax plus c. And integral, if there is no x term, integral of e power x will be equal to e power x plus c. Integral sine ax dx is equals to minus 1 by a cos ax plus c. Integral cos ax dx is equals to 1 by a sine ax plus c. Integral tan x dx is equals to log mod secant x plus c. Integral cot x dx is equals to minus log mod cosecant x plus c. Integral sin x dx is equals to minus cos x plus c. Integral cos x dx is equals to sin x plus c. Integral cosecant x dx is equals to log mod secant x minus cot x plus c, or else log mod tan x by 2 plus c. Integral 1 by ax plus b dx is equals to 1 by a log mod ax plus b plus c. Integral of any constant is equals to cx plus the constant value k. Integral of secant square x dx is equals to tan x plus c. Integral cosecant square x dx is equals to minus cot x plus c. Integral secant x into tan x dx is equals to secant x plus c. Integral cosecant x into cot x dx is equals to minus cosecant x plus c. Integral 1 by a square plus x square dx is equals to 1 by a tan inverse x by a plus c. Integral 1 by a square minus x square dx is equals to 1 by 2a log mod a plus x by a minus x plus c. Integral 1 by x square plus minus a square dx is equals to 1 by 2a log mod x minus a by x plus a plus c. Integral 1 by root of x square minus a square dx is equals to log mod x plus root of x square minus a square plus c. Integral 1 by root of x square plus a square dx is equals to log mod x plus root of x square plus a square plus c. Next, integral 1 by root of a square minus x square dx is equals to sine inverse x by a plus c. Integral 1 by x into root of x square minus 1 dx is equals to secant inverse x plus c. Integral root of x square minus a square dx is equals to x by 2 root of x square minus a square by 2 log mod x plus root of x square minus a square mod plus c. Here there is only a difference of negative and positive. Here it is negative, so everything is minus here, and here it is positive, so in this formula all the terms is in the positive plus form here. Okay, and integral of root of a square minus x square dx is equals to x by 2 root of a square minus x square plus a square by 2 sine inverse x by a plus c. You have to remember all the formulas. They are very important in order to understand the concept of integration. Next is various integral forms. Here we have the integral in various form, and for that specific form we have a formula. You have to remember it. So first one is integral of px plus q by ax square plus bx plus c dx. Means here in the numerator there will be a linear equation, and in the denominator it will be a quadratic equation. Similarly, in the case 2, it is same, but in the denominator there is a root for the quadratic equation, and here they are in the multiplication form. Okay, so whenever there is a numerator and a denominator, and the numerator is in the linear equation and the denominator is in the quadratic equation, you should use this formula. Okay, for the numerator, px plus q is equals to a into d by dx of the denominator quadratic equation plus b. And if the integral is in the form of sin x plus b cos x by c sin x plus d cos x dx. So here there is a sine and a cos, and there is a constant term before the sine and cos. So it is given by the equation a into d by dx of the denominator plus b into denominator. And the third form is they are having a constant term with the sine and cos. So there's a sine, cos and a constant term. So the formula will become numerator is equal to a into d by dx of the denominator plus b into denominator plus c. Here there is again a c term, okay, because of the constants. Next, fourth is integration by parts. Here we shall use the method for the isolate in order to get the f of x and g of x. Okay, I is inverse L logarithm algebraic a t trigonometric equation, and e is exponential. This is the order to get the value of f of x and g of x. Okay, so integral of f of x g of x dx is equals to f of x integral g of x dx minus integral f dash of x into integral g of x dx whole dx. Here if there is a numerator, we have this rule, right? Numerator is equal to a by d by dx of the denominator plus b. Now in the third case, here we don't have any numerator. Here they are in multiplication form, right? Linear equation into root of the quadratic equation dx form will be there. So in this case you have to put that linear equation is equals to 1 by t. Px plus q is equals to 1 by t. Okay, and there are two more formulas which you need to remember. They are integral of f dash of x by root f of x dx is equals to 2 root f of x plus c. and integral f dash of x by f of x dx is equals to log mod f of x plus c.